Chris can mow a lawn in 40 minutes. Zach can mow a lawn in 60 minutes. How long would it take them working together to mow the lawn? We're going to start with our let statements, just like we do with any word problem. They're asking us how long would it take them working together to mow the lawn. So we're going to let the time it would take them together be x. That's what we're trying to find, so that's going to be the unknown. Now what we're going to do is we're going to set up a table to organize the information here. And the relationship between the different quantities in these shared work problems is rate times time equals work. And in this case, we have two people. We have Chris and Zach. Now, we need to know Chris's rate of work. And a person's rate of work is the reciprocal of the amount of time it takes them to do a job on their own. If it takes someone 4 hours to do a job, we could say that they can do 1/4 of the job per hour. That's their rate. If someone can do a job in 30 minutes, they can do 1/30 of the job per minute. We can take the amount of time it takes someone to do a job and turn that into a rate of work by taking the reciprocal. So in this problem, we're told that Chris can mow a lawn in 40 minutes. So his rate of work is going to be 1/40, meaning he can mow 1/40 of the lawn per minute. Zach can mow a lawn in 60 minutes, so his rate of work is going to be 1/60, meaning he can mow 1/60 of the lawn per minute. With all of these shared work problems, we're always going to be looking at individuals' rates, and those are going to be the reciprocals of how much time it takes them working alone. Now for the time column, we're always dealing with time working together. These are shared work problems, so we're always interested in how long it takes them when they're working together. And that's actually what they're asking to figure out, so we've decided that that was x. So in this case, the time that they work is going to be x. And the work is always rate times time. So we're going to multiply across. 1/40 times x is going to be x over 40. And 1/60 times x is going to be x over 60. Now we have one variable here, so we're going to need to set up one equation that models the situation. Usually we look for the piece of information that we haven't used yet, and it might not be clear here, but the piece of information that we haven't used is that they are mowing one lawn. It asks them how long would it take them working together to mow the lawn. Since they're looking to mow one lawn, that means the total amount of work they're going to do is 1. If it was 2 lawns, it would be 2. If they were mowing 8 lawns, the total work would be 8. But in this case, the total work is 1. So what that means is that the work Chris does, x over 40, plus the work Zach does, x over 60, has to equal a total of 1 for one lawn mowed. Now we have an equation. We can solve for x. Whenever we have an equation with fractions, we want to multiply by the least common denominator. In this case, that's 120. So we're going to multiply both sides by 120. On the left, when we distribute, 120 times x over 40 is going to end up being 3x. And 120 times x over 60 is going to be 2x. And then on the right, 1 times 120 is 120. And when we combine like terms, 3x plus 2x is 5x. So we have 5x equals 120. And if we divide both sides by 5, that gives us x equals 24. So if we go up to our let statement, x is 24. And since that was time, And in this problem, time is measured in minutes. It's going to be 24 minutes. So our conclusion is it would take them 24 minutes working together, which is a reasonable answer. We know that Chris can do it in 40 minutes working alone, but he has Zach helping, so it should take less than 40 minutes. So our answer of 24 minutes ends up being reasonable.